Welcome. So in this video, we're going to go through this past exam question. It is taken from the 2012 paper, exam 1, question 8. All right, let's give it a read. It says, 8 activities, A through to H, must be completed for a project. The graph above shows these activities and their usual duration in hours. The duration of each activity can be reduced by 1 hour. To complete this project in 16 hours, the minimum number of activities that must be reduced by 1 hour each is which of the following? The first thing you need to recognize here is that we're reducing some activities here and we can reduce by 1 hour, and we're trying to complete the project in 16 hours. So what should be going through your head right now is this is a crashing problem because we're reducing the time of activities, and therefore what we're doing, if I say it very formally, we're reducing the duration of one or more specific activities so that the length of the overall project, the critical path, has been reduced. So that's what we're doing. That's how we know we're dealing with a crashing problem here, because we're talking about reducing the time of an activity. All right, how should we approach this question? Well, I think the best way to approach this question is to consider all the different pathways of it. So let's go into it. The different pathways for this activity would be what? Well, I could go this way, A, E, G. So I'll write that down, A, E, G. Now, if I was to go A, E, G, I'm going to get 6 plus 4, it's going to be 17. So I'm just adding them all up. I went 4, 6 is 10, plus 7 is 17. And then what else could I do? I could go this way as well. So this would be A, F, H. And if I went A, F, H, it would be 7 plus 5 is 12, plus 6 is 18. What else could I do? I could go A, B, C, E, G. All right, let's write that down. So I could go B, C, E, G. All right, so that's going to be 3 plus 4 is 7. 3 plus 4 is 7, plus 6 is going to be 13, plus 4 is going to be 17. Perfect. We keep on going. What else could we do? We could go B, C, F, H. B, C, F, H. And if I did that, I'm going to end up with 3 plus 4 is 7, plus 5 is 12, plus 6 is 18. And then the last thing I could do is I could go B, C, D, H. All right, B, C, D, sorry, I've got too many. B, D, H, my bad. B, D, H. All right, so that's going to be 3 plus 4 is 7, plus 6 is 13. All right. Once we've gotten here, I'm actually going to do something. I'm just going to take a copy of this because there's going to be different ways we can approach this, and I want to see those different ways. So I'm going to just take a copy of it. We'll pop it here. And while we're here, let's take another copy of it because I want to see the different ways of doing this. So I'll take 3 copies just in case. All right. It then says that what we need to do here is to complete the project in 16 hours, and the duration of each activity can be reduced by 1 hour. So if we can reduce an activity by 1 hour and we want to get to 16 hours, we have to figure out the minimum number of activities that must be reduced by 1 hour each. All right, what could we do here? Well, the first thing I would do is I would kind of circle the minimum time is currently going to take to complete this project. So in other words, the critical path. So the minimum completion time or the critical path is going to be 18 because that's my biggest number at the moment. So now I'm going to say, well, how can I take this and turn it into 16? So what I would do is I would look for what is shared between this pathway and that pathway. Well, they both have F and they both have H. So what I could do is I could make the following reductions, and I'll write it here. We're going to make the following reductions. I'm going to make a reduction to F and I'm going to make a reduction to H. And when I do that, so I'm taking an hour off F, I'm taking an hour off H, so I'm making 2 reductions, and that's going to take me to 16. Now, this is where people are going to absolutely mess up this question. They're going to go, well, I've done it. Let me just rule this off. Well, I've done it. My answer is going to be 2. I made 2 reductions and I got it to 16. I'm a genius. They move on. But they would be wrong. And the reason why they would be wrong is because you have now created a new critical path. You've created a new minimum time to complete this activity. Because remember, it's going to be your biggest number. So now 17 is going to be the minimum time it takes to complete this project, and therefore the critical path. So you're actually going to have to make another reduction in order to make this 17 16. So what you're going to do is you're going to look at these 2 things and you're going to go, all right, what do they share in common? Well, they share in common E, they share in common G. So you could reduce either E or G. It doesn't matter. Let's just choose G. we can reduce G here. And by doing that, I'm going to say, well, this now becomes 16 and this now becomes 16. So now I've made a third reduction, 1, 2, 3. I've made 3 reductions here. And by doing that, I've got 16, 16, 16, 16. This 16 is showing me that this is the minimum time it takes to complete this project. 16 will be, because there is no bigger number. This 13 doesn't come into play. So that means 16 is now the time it takes to complete this project. So how many reductions do we have to make? We have to make 3 reductions here. So my answer is going to be 3. That is the important point. And again, can I stress, the thing that people mess up is not recognizing that as soon as you start reducing things and you get to your desired outcome, they think that's the desired outcome straight away. It's going to be 16 there. But you have to consider what new critical paths have you created by doing that reduction. And then you have to counter those by making reductions to those as well, if need be. All right, let's now look at the examiner's report, and then we'll talk a bit more about how people have also done this. All right, so let's come over here. Let's look at the examiner's report. The funnest part of it all, the examiner's report. What question is this? This is question 8. Question 8, how many people got it? 30% of people were able to answer this correctly. Let's now read what VCAA has said. While the first 6 questions in Module 5, Networks and Decision Mathematics, were well answered, questions 7, 8, and 9 were challenging for many students. In answering question 8, it was necessary to realize that there were 2 paths, AFH and BCFH, of a length of 18 hours, the critical paths. So notice that is what we said. So let's look at our fresh one here as we're reading through it. So the first thing that is said that we had to notice was the fact that we have AFH, and BCFH have 18 hours, and therefore this is our critical paths. It then continues on to say, and 2 paths AEG and BCEG of a length 18 hours. So AEG is 17, BCEG was 17 hours. We also had to recognize that, and that's what we did do up here. Now, VCAA has answered this a little bit differently. It gets you the same answer, they've just used a bit of a different way of doing it. What they have now said is to do the following. They have said, reducing activities A and B by 1 hour each reduces the lengths of the 2 paths to 17 and 16 respectively. So what VCAA has done here is said, all right, let's reduce A and let's reduce B. So the reductions that they have made, is A and B. So they've made 2 reductions so far, and that's going to just take everything down by 1. So 18 becomes 17, 17 becomes 16, 18 becomes 17. And notice what they say. So now you've got 17 and 16 hours respectively for these pathways, which is what you can see here. Now it says, let's grab the highlighter back, reducing either F or H by 1 hour will then further reduce the critical paths AFH and BCFH to 16 hours as required. So notice it's drawing our attention to AFH and BCFH because they're currently 17. So 17 here would be now our minimum time to complete this project. But now we want to get this 17 and make it 16. So that means what we're going to have to do is look for what is shared between this one and this one. All right, so as you can see, VCAA is telling us that we could either reduce F or H because they both have F in common and they both have H in common. So either one of those would be fine. Let's choose H. Let's reduce H of these. So now we've made a third reduction here, and our third reduction is for H. And by doing that, this becomes 16, this becomes 16. So now 16 is going to be the time it takes to complete this project. So as you can see, 1, 2, 3 number of reductions had to take place here for this to be possible. Okay, so let's read the last little bit that VCAA has to say to us here. It says, it was not sufficient to just reduce the length of AFH and BCFH to 16 hours. For example, by reducing the duration of F and H by 1 hour each, because it will still take 17 hours to complete the activities of AEG and BCEG. That right there is so very important and kind of gets to the crux of crashing. The fact that what it's saying here is you can't just reduce F and H from these 2 pathways. And remember, that's the first thing that we did. So remember what we did is we said, oh, look, we've got 18, 18. Well, what do they have in common? They have H in common. And what else do they have in common? They have F in common. And we said, all right, if we make those 2 reductions, what we're going to end up with is 16, 16. And people thought they were done because they got 16. But what they didn't realize is that it would still take 17 hours to complete the activities on pathways AEG and BCEG. Look, 17. So therefore, you have to make a third reduction to one of these in order to get it to 16, to make these 16. And that's what we did up here. All right, I've probably talked to death about this question, but hopefully you can walk away with a really well-rounded understanding of it and feel comfortable with it. Because as you can see, only 30% of the state was able to get that correct. Look, 30%. So if you can understand it, you're going to be well ahead of many people in the state, which is what we want, isn't it now? All right, I'll see you later.